Hi, hello. Now we are going to do more practice in kinematics of linear motion by doing self-exercise 8.1 from textbook. Okay, question number 1. A particle moves along a straight line and passes through a fixed point O. Its displacement s meters from O is given by s equals to 2t squared minus 3t plus 6, where t is the time in second after the motion begins. Okay, calculate A, the instantaneous velocity of the particle in meter per second. Okay, so first of all, we do this as VA, this diagram, as to V differentiate, V to A differentiate another time, A to V integrate, don't forget plus C, V to S integrate another time. Okay, so now for question A, we are going to find instantaneous velocity, meaning that now we have S, we are going to find V. Okay, so V is actually ds dt. Okay, so then V, we differentiate, we will get 4t minus 3. Okay, so now A1, okay, A1, find value of V when t equals to 1 over 4. We substitute V equals to 4 times 1 over 4 minus 3 equals to negative 2 meter per second. Okay, so then when t equals to 2, V equals to 4 times 2 minus 3. Okay, equals to 5. Then when t equals to 6, okay, V equals to 4 times 6 minus 3 equals to 21 meter per second. For question B, calculate the time in seconds when the instantaneous velocity of the particle is negative 1 meter per second. Okay, so previously from A, we got V equals to 4t minus 3. So the first one, when V equals to negative 1, we are going to find the value of t. So 4t minus 3 is negative 1, 4t is 2, t is 1 over 2 second. Okay, 2 when V equals to 5, V is 40 minus 3 equals to 5, 40 equals to 8, then T equals to 2 second. And the last one, when V equals to 9. So V equals to 9, 40 minus 3 equals to 9, 40 equals to 12, then T equals to 3 second. Now number 2, a particle moves along a straight line. Its displacement s meters from the fixed point O at time t is given by s equals to 2t cubed minus 5t squared plus 4t. Okay, then A, find the instantaneous velocity when t equals to 2. Okay, first of all, you do the SVA, differentiate this one, integrate, don't forget plus C. So then integrate another time. Okay, so now this is your S. Okay, so now for question A, we are going to find velocity. So V is ds dt. Differentiate with respect to t. Okay, so this one becomes 6t squared minus 10t plus 4. Okay, so find velocity when t equals to 2. So then substitute when t equals to 2, V equals to 6 times 2 squared minus 10 times 2 plus 4. Okay, so this one equals to 8 meter per second. B, find the values of t in second when the particle stop instantaneously. So stop here, V equals to 0. Okay, so this is our V. So then we need to equate to 0. Okay, so now 6t squared minus 10t plus 4 equals to 0. Okay, so then this is quadratic equation. So to solve this, you need to factorize. So this one become 3t squared minus 5t plus 2 equals to 0. So 2, this one is 3t, t minus 1 minus 2. Okay, so now we will get t equals to 2 over 3 and t equals to 1. Okay, then for question C, Okay, find the range of values of t in seconds when the particle moves to the right. Okay, so move to the right, move to right. Meaning that v is more than 0. Okay, just now this is our v. So 6t squared minus 10t plus 4 is more than 0. This is quadratic inequalities. So this one, we just take this one. Okay, so 2, 3t minus 2, t minus 1. So more than 0. Okay, so we try to draw, sketch the position of this inequality. So this one t is 2 over 3, this one t is 1. So this one is 2 over 3, this one is 1. Okay, more than is right here and right here. Okay, so meaning that for the left side, so we get 3 is t is less than 2 over 3, and the right side t more than 1. Okay, but this one t is time. Okay, time is quantity of scalar, always positive. So you have to limit this one t less than 2 over 3. This one you must put t more equals than 0. Okay, because t always positive. Okay, now we are going to continue in self-exercise 8.5. Okay, question number 1. A particle moves along a straight line. Its velocity v meter per second, t seconds after passing through a fixed point O is given by v equals to 8t minus t squared. Okay, so this is our v. Okay, so A, find the initial acceleration in meter per second squared of the particle. Okay, so before do kinematics of linear motion, we always start from this SVA. So S to V, differentiate another time. A to V, integrate. Don't forget plus C. C to S, integrate another time. Okay, so now we are going to find initial acceleration. We got V, so we need to differentiate. So A is actually ds dt. So A equals to 8 minus 2t. Okay, so this is acceleration. Okay, so now initial. Okay, initial meaning that t equals to 0. Initial acceleration t equals to 0 into A. So A equals to 8 minus 2 times 0 equals to 8 meter per second. Okay, B. Find the acceleration when the particles stop instantaneously for the second time. Okay, so the word of stop. Okay, the word of stop. V equals to 0. Okay, so this one from the function V. So 8t minus t squared equals to 0. Then we factorize 8 t times 8 minus t, okay, equals to 0. Then t equals to 0 and t equals to 8. Okay, so we need to find the acceleration for when the particles stop instantaneously for the second time. Okay, second time meaning that when t equals to 8. Okay, so when t equals to 8. Okay, so then we substitute t equals to 8 into acceleration, into A. Okay, so when t equals to 8, A equals to 8 minus 2 times 8, which is equals to negative 8 meter per second squared. Okay, sorry, this one is meter per second squared. Okay, so C, find the time in second when the velocity is uniform. Okay, so the clue here, we got velocity uniform. So C, uniform velocity. Okay, uniform velocity, A equals to 0. Okay, so when A equals to 0, this is our A. So A is 8 minus 2t equals to 0. So we are going to find the time. So t equals to 4 seconds. Number 2, a particle moves along a straight line so that t seconds after passing through O. Its velocity v meter per second is given by v equals to t squared minus 2t minus 8. Okay, so then A, find the time, okay, meaning that t, in seconds when the acceleration of the particle is 0. Okay, start from here as VA. So differentiate, another time, this one integrate. Okay, so then to find acceleration from V, okay, so we need to differentiate. So A is dV dt. So A equals to 2t minus 2. Okay, so acceleration is 0. So 2t minus 2 equals to 0, t equals to 1. Okay, B, find the range of values of t in second when the particle experiences deceleration. So decelerates. Okay, decelerates. Okay, decelerates A less than 0. Okay, so this is A. Okay, so less than 0. 2t minus 2 less than 0. Then t less than 1. But don't forget t always positive. So you must put the range t more equals than 0.